In this video, we're going to discuss compound fractions. Sometimes they're known as complex fractions. Different textbooks call them different things, but they're all about the same. And so our notes will involve first a definition that will help us get through simplifying these. Let's talk about what's called a minor LCD. So the minor LCD is the LCD of all the minor denominators in a compound fraction. Of course, that may make you wonder, well, what's a minor denominator? So this is not an official term, but I think it helps understand the structure of a compound fraction. Let's see an example of one here. If I had one large fraction, I'm going to kind of create one from nothing here, leave a very big space in the numerator and the denominator. A fraction like this would be considered compound or complex if this major numerator contained fractions within itself. So you might see a numerator up here such as 1 over x plus y over 2 or something. It has fractions within it. Or maybe the major denominator could be something like 1 minus x over y. So when you have fractions within a fraction, that's what we mean when we say compound or complex fraction. But then, okay, what's a minor denominator? Good question. A minor denominator would be any of the little denominators that you might see within the fractions that are within the fraction. Okay, so yeah, it can get a little crazy, but those small, and I mean small as in font size, they look small compared to the larger picture. Those are the minor denominators, and so the LCD of them is really no different than it has been finding an LCD. So the minor LCD would simply be the LCD of those minor denominators. In the cases of these we're looking at here, which are x, 2, and y, of course the LCD of those would be 2xy. So that's all we mean when we say minor LCD. It's finding the LCD of the little denominators that are within the larger complex fraction. Now let's look at an example of one of these and see if we can simplify it. It's a little difficult to read these off clearly, but I'll do my best here. This compound fraction has a major numerator and a major denominator. In the major numerator, we'll find the expression x cubed over x plus 1. And in the major denominator, we'll find the expression x over x squared plus 2x plus 1. That trinomial being the denominator of that minor part, the minor denominator. To find the minor LCD, it would be just as if we were finding the LCD of these minor fractions, and as we've seen, we have to factor in order to find that. The bottom minor LCD, which originally read was x squared plus 2x plus 1, can be factored as x plus 1 squared. And so if we consider x plus 1 squared as one of the minor denominators, and then just x plus 1 as the other, the minor LCD of those would simply be x plus 1 squared, which is, yes, the highest power of that common factor. Now, what we do with the minor LCD is what will help us simplify this fraction. So let's try this in that I want to rewrite the original problem as it was. So remember, the major numerator was x cubed over x plus 1, and that was all over the major denominator, which was x over x squared plus 2x plus 1. Now we're going to multiply the major numerator and the major denominator, the two big pieces of this original fraction, each by the minor LCD of x plus 1 squared. So I'm going to multiply by x plus 1 squared in the major numerator and x plus 1 squared in the major denominator, and then do our reducing, kind of like we've been reducing rational expressions thus far. You'll find in the major numerator that the x plus 1 original minor denominator will cancel with one of the x plus 1's in our minor LCD, leaving one behind, and we could distribute then the x cubed from the minor numerator to both of those terms, resulting in a major numerator of x to the fourth plus x cubed. Then we'll go downstairs in the major denominator and do the same thing. This minor denominator was x plus 1 squared, which will cancel completely with the minor LCD, leaving us only with x. And then we'll simplify this by splitting and dividing. X to the fourth over x is x cubed, plus x cubed over x is x squared. And so x cubed plus x squared is our simplified result. Let's consider another example of something similar. This compound fraction has a major numerator of x over y minus y over x, and a major denominator of 1 over x squared minus 1 over y squared. Now, of course, we care to find the minor LCD out of all this, for which we'll be considering the minor denominators, which are y, x, x squared, and y squared. Given all of those, the minor LCD would be the highest power of any common factor of those, which would be x squared, y squared. So we're going to multiply the minor LCD times the original problem. And so let me rewrite this original problem, which had x over y minus y over x as the major numerator. And then that's all over the major denominator of 1 over x squared minus 1 over y squared. So we'll multiply the major numerator by x squared y squared and the major denominator by the same x squared y squared. Again, that all coming from what we found as the minor LCD. Now, when I multiply, I distribute to both terms, top and bottom. Things will start to cancel. For example, when this x squared y squared in the numerator collides with the first term x over y, the y squared from that minor LCD will reduce with the y from that minor denominator, giving us on top an x cubed. That's the x times the x squared. But then the y squared over the y will cancel and turn into just a single y being multiplied with that x cubed. If we carry this idea through as we distribute, we'll notice then we'll be subtracting, and the next above, when we take the minor LCD inside, the x will cancel with the x squared, and the y's will combine, giving us y cubed times x. And then down in the denominator, we'll follow the same example. This time more cancels out. When I take the x squared y squared minor LCD and distribute it to the first minor term of 1 over x squared, I'll end up with simply y squared. The x squareds would cancel out. And then in the second term, of course I'll keep the minus between them, the y squareds would cancel out, giving us just minus x squared. Now this result does seem to hint that it might be simplifiable, so we should try to do that, and we'll try that by factoring each part, numerator and denominator, and then seeing if anything cancels. So let's go ahead and take a few steps in that direction. In the numerator, it does see that there is a GCF we could factor out, and that would be xy. If I factor that out, I'll have x squared minus y squared. And you'll notice down below that almost matches our denominator of y squared minus x squared. In fact, we've seen this before. All I wish I could do was switch the order of these two terms so that they would match as x squared minus y squared with the numerator factor, but we can do that simply by factoring out a negative. So we'll do that next. If I take a negative out front, I'm going to leave the numerator as we had it, xy times x squared minus y squared. But then in the denominator, I'm going to switch the order of these terms, which will now be x squared minus y squared. So then the x squared minus y squareds cancel, which leaves us only with minus xy. Let's do one more example quickly here. We have x plus y over x all over y plus x over y. And so we'll consider the minor LCD of this expression to be simply xy, considering both minor denominators of x and y. And then we'll multiply that minor LCD times the original problem, which we'll rewrite to do. There's the major numerator, x plus y over x. We're going to multiply that by xy. And then the major denominator, y plus x over y, will also multiply by xy. When we multiply by the xy minor LCD, we'll be distributing it into both terms, top and bottom. Of course, things will cancel in some cases when we do that. So in the major numerator, we'll end up with x squared y for the first term, plus, in the second term, the x's will cancel, giving us only a y squared. And then in the major denominator, with the same process, we'll end up with xy squared plus, this time the y's will cancel, giving us just x squared. Now, it can be very tempting at this point to try to start canceling things, but we have to be very careful to factor before we cancel anything, as always. So let's try factoring and see where this goes. In the numerator, there's a GCF of y, and if I factor that out, I'll be left with x squared plus y. In the major denominator, there's a GCF of x. If I factor that out, I'll be left with y squared plus x. And now if we look carefully at what we have, it seems very tempting to try to cancel something, but you'll notice factors that are in parentheses have to stay together in parentheses like a family. Do not split it up. And if that's true, then there is no factor that will match for the numerator and denominator here, which means we're done with what we have here.